Today we're going to talk about perpendicular and parallel lines. We talked about this actually last time, really. It's a review, okay? We want to talk about it a little bit more in depth though, but it's really the same thing as what we did last time. So, first of all, what kind of lines are perpendicular lines? What sort of, how do you know that two lines are perpendicular? What tells you? Yes, Angel? Yes, the two lines must intersect, and not only do they have to intersect, but they have to make what kind of angle? That's correct. All right. So here's some examples. Okay. So any two lines that intersect to form right angles are perpendicular. Okay. So here's some examples. I have two lines. By the way, can I have a horizontal line and a vertical line that make? What do you know about a horizontal and a vertical line? They're always perpendicular, right? Horizontal and a vertical line. But they don't have to be horizontal and vertical. It could be like this, right? So write that down. Here's some examples of horizontal, perpendicular lines. Okay. Okay. So what about parallel lines then? What kind of lines are parallel lines? Carolyn.
They're even and they never touch.
That's right. They do not intersect. So here, two lines that do not intersect are called parallel lines. And here's some examples. Okay. Example, the first one, two lines like this, and then of course two horizontal lines, right? Aren't they parallel? Of course, two vertical lines are also parallel, but like they don't have to be horizontal or vertical every time, right? So it could be these two lines. All right, so write that down. And so two lines that do not intersect are called parallel lines, right? So oh wait, yeah, good. There is a symbol for perpendicular, right? The upside down T kind of looking. And for parallel line, what's the symbol for parallel lines? It's like two kind of lines like this. Yeah, like that. That's the symbol for parallel. Okay. All right, may I move on? Need more time? Okay, I'll wait. Go ahead, write it down. Okay, then take a look at this. What about these two lines? Look, these two lines look like they don't intersect. So are these two lines parallel?
Nope.
No. Okay. Why not? Look, they don't intersect, right? Chuck, why not?
They're just about here.
Yeah, and not only that, what do you know about lines? They extend infinitely. They extend forever. So the red one and blue one, they're going to intersect at some point. Just because it looks like they don't intersect, it doesn't mean they're parallel. So what do we call these kind of lines? Are these perpendicular lines? No, because there isn't 90 degrees marking or anything. So what do we call these lines that intersect? They're just intersecting lines, okay? They're not perpendicular or anything like that, right? So they're just called intersecting lines, okay? All right. So it turns out, let's then talk about in terms of their slope. We learned this last time. Remember, I even showed you the cool kind of illustration. What do you know if two lines are parallel? What do you know about their slope, class? They have the same slope, remember? And they have a different y-intercept, right? Does that make sense? Because if they have the same slope and same y-intercept, guess what? Two lines are the same line, right? It turns out, of course, you have to have a different x-intercept too, but if you have the same slope and the x-intercept, it's the same line again, right? Anyway, so if two lines are parallel, they have to have the same slope but different y-intercept. Okay? Of course, if you have different y-intercept, you can have different x-intercepts too. They have the same slope. Okay. All right. So that's fact one. Remember, this is a review, right? So write that down. People are still writing. Okay. All right. Then who remembers the second fact we learned last time about perpendicular lines in terms of their slope? We know that if two lines are perpendicular, what do you know about their slope? Remember we talked about this last time. How about, okay, some of you remember. Okay, how about Libby? How many people agree with Libby that product of the two slope must be -1? You guys are correct. And remember, there was one exception, right? You guys remember there was an exception. So, but all the other cases, this is true. So in a plane, two lines are perpendicular if and only if the product of their slope is -1. Who remembers the exception? Okay, some of you. Okay, go ahead. Write this down first, and then as you write this down, think about the exception. There's one exception. Right? There's a case where when you multiply the two slopes, it doesn't become -1, even though they're perpendicular. Okay, go. Okay, as you write this down, think about it. Okay, go ahead. I'll wait. All right. Who remembers when you have an exception? So there is a case when two lines are perpendicular, but when you multiply their slope, you don't get -1. When does that happen? 1, 2, 3 people see it? 4? All right, Carolyn, what do you think?
When it's undefined and
When is what?
undefined.
Okay, and?
And it's
Okay, what does that mean? Okay, Patty?
When the lines are horizontal and vertical
Exactly. When the two lines are horizontal and are vertical, right?
I said
Because yeah. But I know what you mean. But Carolyn, then, what's the slope of a horizontal line? What is the slope of every horizontal line? Remember, horizontal line what? It's 0, right? Because remember, it's rise over run. Horizontal line, there is no rise, right? So therefore, it's 0. What's the slope of a vertical line? Michael? Undefined. So when you multiply 0 times undefined, do you get negative 1? No. But the two lines are perpendicular. So write that down. So here we go. Okay. So there's exception. Horizontal and vertical line. So horizontal line slope is 0. Vertical line slope is undefined. Therefore, the rule doesn't apply for horizontal and vertical line. But everything else, it works. Okay. Everything, all the other lines. Okay. When you multiply their slope, like for example, if slope of one line, and we call it m sub 1, is equal to 2/3, m sub 2 equals to negative 3 over 2. When you multiply it together, you get negative 1. Therefore, the two lines that has a slope of 2/3 and negative 3 over 2 must be perpendicular. Okay, so I'll wait for you guys. Write it down. By the way, what do you think the m sub 1 and m sub 2 represent? Slope from the? No, m sub 1 right here. M sub 1, it just means slope from the first line, and m sub 2 is the slope of the second line. Okay, so that's all. I remember when we did y sub 2 minus y sub 1, and so it's kind of similar idea. Okay. All right. Do you guys remember how I showed it to you with some illustration? Let's do it again. Let me just show it to you again. So here, here's the program. Let me put an equation. Let's put y is equal to 2x plus 3. Okay. Let me make it a little bit. Thank you. Let me make it a little bit thicker. The line. Here we go. All right. I have an equation that says y is equal to 2x plus 3, right? Somebody give me an equation of a line that is parallel to this line. By the way, how many lines are there that is parallel to this line? How many lines are there that is parallel to this line? Infinitely many, right? Because how many lines are there that has a slope of 2, right? Yeah, infinitely many. Somebody give me, so there are infinitely many lines that has a slope of 2. Somebody give me another one. How about Dana? Can you give me an equation of a line that has a slope of 3? I mean, slope of 2. Yeah, y is equal to 2x plus what? 4, sure. Okay, so let me duplicate that one. There you go. So instead of 3, you want just everything else is same, right? The slope is same. You just want to change this to 4. There you go. You see? You can see that the two lines have the same slope, right?
Wait, can you make it to?
Yeah, hold on. Let me actually edit this and move this down a little bit so they're not so close. How about negative? What would happen if I change it to negative 2? Negative 1. How about negative 1? It'll go down right there, right? You see how they have the same slope? And remember what I did was I changed the slope of both of these and to m, right? You guys remember? If I make that m, right now the m is 0. That's why you get a horizontal line. You see that? Okay, so if I have these two lines have the same slope, and if I now, let's change the value of m. Look what happens as I change the value of m to, I don't know, negative 3. You see how they're still parallel because slope of both lines are same. And I could actually move it automatically. Right, you guys remember we did this last time, right? No matter which slope you plug in, because we're using the same slope for both of these, right? Slope of both is m, right? They remain parallel, all right? So who remembers then how to make this so that two lines are perpendicular all the time? So one of them has a slope of m. What do I need to do for the other one so that they're perpendicular all the time? How about Claire? So one of the line has slope of m. The other line must have a slope of what so that they are always perpendicular? M also? We just said if one of them has a slope of m, the other has m also, they're parallel. We want to make them perpendicular.
Oh, okay.
So what do I need to do? Change one of the slope to? Let's change one of the bottom. What would you like to change it to? Remember, what do you know about perpendicular lines? Their slope must be, when you multiply them together, must be? No, that's the slope-intercept form, y equals mx plus b. Look at your notes. What do we have to have in order for two lines to have perpendicular slope? Their product of their slope has to equal to what? That's the second fact. Negative 1. So if the first line has a slope of m, what must the slope of second line be? Negative 1? Let's try. Let's try negative 1. Okay, if I do, oh, it looks like there, but if I change the value of m, it doesn't do anything, right? Is m times negative 1, does that give you negative 1?
Yeah.
Really? M times negative 1 give you negative?
I know.
M times what gives you negative 1? Not negative 1, but...
Negative. Wait, 1.
Okay. No, Claire, if I have m times what gives you 1? Like 3 times what gives you 1? 3 times?
1. Wait.
3 times what gives you 1?
Isn't that division?
Right, so I'm asking a simple question. If I have a number 3, 3 times what gives you 1?
Nothing.
Remember reciprocal?
Because 3 times 1 is 3.
Yeah, so 3 times what gives you 1?
Oh, 1/3.
It's reciprocal, remember?
Oh, wait, oh, yeah.
So what do I need to multiply m so that I get negative 1?
1 over m.
Yeah, but then I wanted to negative 1.
Oh, negative.
Negative 1 over m is correct. So remember, if we did this, 1 over m is negative in front. There's negative in front. Let me actually put negative here inside. Does that make sense? So let's see if they're going to be perpendicular. Look, it looks good right now. And if I make a change, see, the change. If I change the value of m, as you can see, that it remains perpendicular throughout because m times negative 1 over m gives you negative 1 every time. You see how product of their slope gives you negative 1? Does this make sense? Right? M times negative 1 over m, right? If you don't believe me, let's multiply it out, right?
Well, how do you graph that?
Well, m could be any numbers you want. Look, if I have a slope of m, right? M times negative 1 over m, what does that give you guys? Negative 1, right? Well, m is any number you want. M is a slope. M could be any values you like. Carolyn, m could be 5. Then what is negative 1 over m?
Negative 1.
Yeah, so when you multiply it together, don't you get negative 1? M could be half. What's negative 1 over m? If m is half. 1 over, negative 1 over half, which is negative 2, right? So what's half times negative 2? Negative 1, right? So, right? That's, remember, you guys remember opposite reciprocals? These slope has to be the opposite reciprocal of each other, right? Does this make sense? Do you guys remember this?
Yeah.
All right. So if that's true, okay, as you can see, even if I change the value of m, they remain perpendicular throughout. Does that make sense? Yes? Hello? Okay. Example 1 says, show that y equals to 3 over 4x minus 1 and 6y equals to 8x plus 7 are perpendicular. How can I show that these two lines are perpendicular? How do you show this? Any idea? It says show that y equals to 3 over 4x minus 1 and 6y plus 8x equals to 7. Yes, Carly?
Well, first you have to solve for y on the bottom one.
Good. Why do you want to solve for y for the second equation?
So you can track the slope.
That's right, so you can find the slope. How come we don't need to do that for the first equation?
Because
It's already in slope-intercept form. Very good. So after we find the slope, how would you know whether or not they're perpendicular? How would you show this? You have to multiply, and if it equals to negative 1, guess what? They're perpendicular. Does that make sense? Go ahead, everybody try. So I'll do the first line 1 for you. It's pretty easy. So line 1, I did it right here. It's already in slope-intercept form. I don't have to do much work, right? You could already tell that the slope is 3 over 4, right? By the way, why do you think I called it m sub 1?
Because there's 2.
Yeah, because there are 2 lines, right? This belongs to the first line, right? What about the second line then? What is the slope of the second line? Go ahead, everybody. Go ahead and find. Okay, I'll wait. All right, so what do we do here to get the y by itself? We're making it into a slope-intercept form. How about Bella? What do I do? Subtracted 8x from both sides. You're right. And then divide both sides by 6. How many people got then the equation? Sammy, what do I get when I do this? Y equals to? Is it over 7 or is it over 7 over 6? 7 over 6. Don't. Yeah, be careful. Don't. You need to divide both of the terms, right, by 6. Very good. Of course, and Sammy said, of course, 8 over 6, negative 8 over 6, you should always simplify. How many people got the slope of the second one, negative 4/3? Raise your hand. By the way, does the y-intercept matter in this case at all?
No.
No, we don't really need to worry about y-intercepts.
Graph that.
No, did I ask you to graph?
No.
What did I ask you to do?
Find if it's perpendicular.
Yeah, see if it's perpendicular. So I didn't ask you to graph, right? All I said was show that the two lines are perpendicular. So all you have to do is then what? Am I done at this point?
Yeah.
No.
Yes.
How do I show? Now, all I have shown is that their slope is 3/4, the other is negative 4/3. Camilla, what do you think I need to do? Yeah, I need to multiply them out, and it should equal to negative 1 if it's perpendicular, and it is. Isn't that right? Because aren't they opposite reciprocal of each other? So on your homework tonight, if they ask you to show that the two lines are perpendicular, this is the work that you need to show. Is that okay? So it comes out to that it shows that the two lines are perpendicular since the product of their slope is negative 1. Easy enough? All right. Okay. So Tajiwar's question is really good. He said, well, what if one of them is horizontal, the other is vertical? It will come out that the slope will be 0, the other is undefined. So you don't, at that point, you don't need to multiply. You just say one of them is horizontal, the other is vertical. Therefore, two lines are perpendicular. That'll be good enough. Okay, good question. All right, let's move on to then next example. Okay. So take a look at example 2. It says find the slope of a line. Find the slope of the line perpendicular to the graph of each line. So here's my first linear equation. 3x minus 5y equals to 110. What do they ask you to find? They want you to find the slope of this line or the other line?
Perpendicular.
Yeah. So are they asking for the slope of this line or are they asking for the slope of the other line that is going to be perpendicular to this?
Another line.
Yeah, another line. They're asking for the slope of the other line that must be perpendicular to this line. Does that make sense? So how do you do that? Well, you need to find first the slope of, yeah, you need to first find the slope of this line by writing as a slope-intercept form. Then you can see what the other line must be. The slope of the other line must be. Does that make sense? So go ahead, everybody, tell me what the slope of this line is first. Then you will know the slope of the other line, what the slope of the other line must be so that they're perpendicular. All right, go ahead, everybody try. Who could tell me what I need to do so that I can find the slope of the line 1, our original line? How about, let's see, pick somebody at random. How about Brianna? What do I need to do here? Good. I need to subtract 3x from both sides. And of course, when you do, you get negative 5y equals to negative 3x plus 110. Right? You want to write negative 3x first because you want to write this in slope-intercept form. Then divide both sides by what class? Negative 5. How many people got y equals to negative 3 over 5x plus negative 22? Okay, good. If you didn't, something went wrong. Okay, most of you did. Guys, then we know that slope of the first line, I mean m sub 1, slope of the first line is 3/5. So here's the question. What must be the slope of the other line so that it's going to be perpendicular to this line? How about Chuck?
It would be negative 5 over 3.
Correct. How many people got negative 5 over 3 as the answer? As you can see, right, what is reciprocal of 3/5? Yeah. No, just the reciprocal. 5 over 3, but then we need the opposite of it, right? So that it becomes negative 1. All right, let's try this next one here. Here we go. This one is kind of interesting, guys. Here, what if I give you this? Y equals to 1. What must the slope of the other line be if they're perpendicular to this line, y equals to 1? I don't know. Okay, what kind of line is y equals to 1, by the way? How do we know it's a horizontal, guys? Yeah, because y is always equal to 1, right? Class? So if you're confused, you can actually do a little table. As you can see, y is always 1, therefore there's no rise, correct? If there's no rise, that means it's 0 over some number. So therefore slope is 0. Therefore, what then must be the slope of the other line if it's going to be perpendicular? Everybody go ahead and write it down. I'll wait. You could help each other out as well. So slope of y equals to 1, which is a horizontal line, is 0, correct? Then what is then the slope of the other line must be? So that they're perpendicular. Go ahead, everybody think about this. Did you all get undefined as your answer? Yeah. Okay. Why should it be undefined? Because who could explain? How about, hold on, how about Lindsay? Why should the other line must be, why should the slope of the other line must be undefined so that they're perpendicular?
Yeah.
No, slope of a horizontal line is 0.
Yeah. So.
And what kind of line has a slope that is undefined?
Sorry.
Vertical line. Therefore, slope of a vertical line is undefined. That's why. Does that make sense? Because if you get an equation y equals to 1, you get a horizontal line, right? So we need a vertical line so that they're perpendicular. And we know that the slope of a vertical line is undefined. Does that make sense? So if you knew this, if you know this now, what if I have this? X equals to -3. What kind of line is x equals -3? Look, x is always -3. Y could be any number you want. What kind of lines do you get? How about Jason? That's right. Because I could do a little table, right? Don't you get a vertical line?
Yep.
So then 1 must be the slope of the other line. Has to be. Well, slope of this line is what? Undefined. So 1 must be the slope of the other line has to be. 0 is correct, right? Because this line, x equals to -3, right? 1, 2, 3. Don't you get a vertical line like this, right? Well, the other line has to be a horizontal line for it to be perpendicular to this, right? Does that make sense? So this line, vertical line, right, has a slope that is undefined. Therefore, the line that is going to be perpendicular to this must be a horizontal line. What kind of line? What kind of slope does a horizontal line have? Well, 0. What is the slope of a horizontal line? It's 0. Easy enough? Does this make sense, guys? Can you do something like this for your homework tonight? Good. All right.